This morning we're going to look at a section of the chapter 3 where we're looking at finding position and nature of stationary points. So I've got an example here of y equals sine of 3x, and we've got a given domain. So the first thing I've done is gone to my calculator, draw that function of sine 3x. Gives me an idea that there's going to be 3 maximums and 3 minimums for the given domain of 0 to 2 pi. And if we're looking at finding or using algebra to do that, we obviously need to use a bit of calculus first. So we're going to find the derivative of that function. Having done now chapter 2, we should know that that's going to be 3 lots of cosine 3x. So the derivative is equal to 0 when we're at a stationary point. So if we find 0 equals 3 cosine of 3x, what we're trying to do is get x by itself. So the first step would be to divide by 3, which is still 0, and then subsequently we would get rid of cos by using the inverse function, bringing that across to the other side. So that would leave us with 3x. The bit that we've got cos in terms of is equal to cos to the negative 1 of 0. And what that is doing, if we go to our graph, and we select the cos x function, is it's telling us where does this function equal 0. What is the x value? What is the independent variable? What is the value of that when we're on the x-axis? So we know there's 2 solutions, and hopefully from our unit circle work we know that those are pi on 2 and 3 pi on 2. So they're going to be our solutions. Just get that graph of sine 3x back up. If we're inverse cos, we said 3x is going to now equal 2 values. The first one is pi over 2, and the second one would be 3 pi over 2. But because it's a cyclic function, we need to make sure we always add in multiples of the period. So for a sine or cosine function, that's always going to be multiples of 2 pi. And the reason we make sure we include that is because otherwise we'll be missing the subsequent solutions. So multiples of the period need to be added. Still one step further to get the x by itself, we're going to divide by 3. So x would then equal, dividing everything on this side by 3, we're going to get pi over 6 followed by pi over 2. If we divide this by 3, the 3's would cancel. And then this is where we need to take into consideration what is the next solution for this given function. And the reason we're going to have a smaller period, remembering from last year's work, is we've changed the period by adding a b value into this original function. So the following solutions, if we're adding multiples of k, are going to be our next maximum, which would occur at 5 pi over 6. Our next minimum over here, which would appear at 7 pi over 6. So we're 2 complete cycles through, and our third solutions, our maximum is going to occur at 9 pi over 6. 9 pi over 6. Or, if we simplify that, that could be 3 pi over 2. And our last solution of the minimum is going to be at 11 pi over 6. So 6 values of x for the given domain. Now that's identified the position, the x value of where that occurs. We still need to find its nature. So to do that, we represent that in a sign diagram. So we go and draw our sign diagram. It will be a little bit messy, but we'll have a straight line with those 6 values marked on it. Obviously, given it's a cyclic function, they will be equally spaced apart. And then because we've got the image of the graph, we just look at the fact that it's going from a positive into a negative, into a positive, into a negative, into a positive, negative, positive. So refresher from topic 1, positive into a negative means we've got a maximum, negative into positive means we've got a minimum, but we could confirm that from our graph on the right hand side here anyway. So 6 stationary points, 3 are maximums, 3 are minimums. In your test, it would be good to just finish that with a statement of max at x equals, and then stating those solutions. Next one of 5 pi on 6, and the last one of 3 pi on 2. And then a minimum at the 3 values of x equals pi on 2, 7 pi on 6, and lastly 11 pi on 6. So a bit of algebra to find those solutions, a bit of refresher from last year's work of adding cycles or adding a period, making sure we add 2k pi, but then that value needed to be divided by 3. So really we're adding 2k pi divided by 3 to get each subsequent solution.